In this video, we will be looking at examples and problems like the problems on 1.6 and 1.7. Numbers 1 through 3 on page 61. 1.6 is page 61. Numbers 1 through 3 involve just taking square roots or cube roots. You can use a calculator, or you can reference the table on page 49 to find those appropriate square roots. I'm looking now at problem number 9. Number 9 says we want the cube root of 27a to the 12th. This little check mark looking symbol we call a radical. This number here is called the index. It tells us what root we're seeking. The expression underneath is called the radicand. So what we're seeking here is what expression times itself 3 times will yield 27a to the 12th. Well, 3 times 3 times 3 is 27. Thus, the cube root of 27 is 3. Here we have a taken to the 12th power. So what term times itself 3 times gives a to the 12th? That's simply a to the 4th. And your shortcut for dealing with the exponent is to simply divide the exponent by the index. So 3 to the 3rd power gives 27, and a to the 4th to the 3rd power gives a to the 12th. With that, take a shot at 10 and 11. I'm now looking at problem number 27. (27) says a to the 3/4 power taken to the 4/3 power. Well, from our class notes, we learned that the power rule says if you have an expression to some power and you're taking that to another power, you simply multiply these two exponents. Well, 3/4 times 4/3, multiplying fractions is very easy. Numerators times numerators, denominators times denominators. This gives a to the 12 over 12. And 12 over 12 reduces to 1, so it's a to the 1st power. I don't have to write the 1. When we see a, it implies a 1st power. I'm now looking at problems 37 through 40. All right, this problem is not 37, but it is like 37. Alright, they ask us to simplify these radicals. So let's say we have the square root of 32. Well, 32 is not a perfect square. There's not one number times itself that gives 32. But we can re-express 32 as a product of a perfect square and some other number. For instance, 32 is equal to 16 times 2. So I've simply re-expressed the radicand. 32 is 16 times 2. Now I can take the square root of this 16. What is the square root of 16? 4. Well, the 4 will come out from underneath the radical and be multiplied by the square root of 2. The square root of 16 is 4. I'll express that outside, and I'll leave the 2 on the inside. So the square root of 32 is equal to 4 times the square root of 2. And you can use your calculator to verify this equality. With that, you should be able to handle 37 through 40. All right, here's one like 55. The instructions on 55 and beyond say rationalize the denominator. Okay. Let's say we have the square root of 3 over 5. Well, first thing, if we have the square root of a fraction, it is equivalent to say it's the square root of both the numerator and the denominator. So I'll change this to the square root of 3 over the square root of 5. These two expressions are equivalent. Well, oftentimes we will be asked to what's called rationalize the denominator. That is, this square root of 5 is an irrational number, and we would like to have a rational number down here. It's a matter of form more than anything else. Sometimes, we, in order to see what it looks like, to have a similar expression that we can look up in the back of the book and all agree on, we have particular rules in math and English and every other discipline where we're going to write it a particular way. So here we're not going to leave this square root in the denominator. In order to undo this square root, I will simply multiply by that. Well, we can't just multiply by the square root of 5 in the denominator. We need to keep this expression the same, so I will multiply by the square root of 5 in the numerator. The square root of 5 over the square root of 5 is 1, so I'm multiplying this expression by 1. I'm not changing the value of this expression. It's equivalent to saying that 1/2 is equal to 3 over 6. How did we do this? Well, we could multiply the 2 by 3 in the denominator and the 1 by 3. So what I've done is I've multiplied by 3 over 3. Well, that's 1. So 1/2 times 1 is still 1/2. We didn't change the value. We didn't change the value. 1/2 is equal to 3 over 6. We just changed the way it looked, and that's what we're doing here. So the square root of 5 times the square root of 5 is 5. The square root of 3 times the square root of 5, you simply multiply the underneath parts together and leave it underneath. Again, the underneath part is called the radicand. Radicand. That's the underneath. Alright. We can multiply the radicands together. 3 times 5 is 15. And it remains underneath the square root. So the square root of 3/5 is the same as the square root of 15 divided 5. You should now be able to complete all of 1.6. 1.7. Number 1. It says the square root of negative 36. Alright, so from our class notes we learned that the imaginary unit I is equal to the square root of negative 1. And don't let this be confusing to you. It's just a way for us simply to handle the square root of a negative. So this number is not in our real number set. So we need some larger number set that accommodates for these square root of negatives. Thus we come up with this I statement. So all I'm going to do, the first thing I'm going to do is rewrite this square root of a negative 36 as positive 36 times a negative 1. Okay. Well, this statement I can write as the square root of 36 times the square root of negative 1. Well, now we have a way to handle this square root of negative 1. We simply call it I. Square root of negative 1 is I. This is I. This is still 36. Well, we know what the square root of 36 is. It's 6. So this expression is simply 6i. Okay. As opposed to showing all these steps every time, anytime you have the square root of a negative, simply change that negative to a positive and write an I outside of our radical. So I'm going from the square root of negative 36 to I times the square root of 36. And now I can take the square root of 36. It's 6. This becomes 6i. Alright, so in this fashion you can see the justification for it, and here on your future problems just do it in this manner. Now I'm looking at problem number 9. Right. It says write I to the 28th as either I, -1, -I, or 1. Well, again, from class notes, we know that I is the square root of -1. I squared is -1. This makes sense. Square root of -1 times the square root of -1 would be -1. Well, I cubed, that is I squared times I to the first, so that's negative this value. We simply write this as a -I. And I to the 4th, well, that would be I squared times I squared. That's -1 times -1. That is 1. Well, this is going to be cyclical. That is, I to the 5th would be the same as I to the 1st. I to the 5th is equal to I. And I to the 6th is equal to I squared. And I to the 7th is equal to I to the 3rd. And I to the 8th is equal to I to the 4th, and so forth. It's just going to continue in this pattern. If you're a 4th power of I, and any multiple thereof, you're going to be 1. So I'm going to rewrite this as some 4th power of I. So I'm going to rewrite I to the 28th as I to the 4th to some power, then times some other product. So in this case, I to the 28th, well, that is I to the 4th taken to the 7th power using our product rule. 4 times 7 is that 28. Well, we know I to the 4th is 1. So this is 1 to the 7th power. Well, 1 to the 7th is just 1. Using this example, you should be able to handle the rest of 9 through 11. I'm going to do number 26. 26 is not in your assignment, but it's remarkably similar to 25. 26 says 4 plus I added with 3 plus 2I. All right. You can treat the I in this context just like it were an X. So essentially we're combining like terms. Since it's an addition, the parentheses have no meaning to us. I can drop the parentheses. So this is the same as 4 plus I plus 3 plus 2I. We're simply going to combine like terms. The constant 4 is like the constant 3. 4 plus 3 is 7. Well, the imaginary terms are also like terms. This is 1I plus 2I. Well, 1I plus 2I is 3I. Consider the imaginary unit I just like you would the variable x, and it'll be no problem here. If there were a subtraction in between, we would need to distribute the subtraction through the second parentheses, and I will do number 30, which will be very similar to number 29 in your assignment. 6 plus 7I subtract 4 plus I. Alright, when there's a subtraction, we will change the signs of the terms in the parentheses behind the subtraction, leaving the first parentheses the same, simply dropping the parentheses. So we're subtracting 4. I'll write that as minus 4. Subtracting plus I can write that as a subtract I. Now it's just like the previous one, combining like terms. 6 minus 4, well, that's 2. 7I minus 1I, that's 6I. Okay. Now I'm looking at 41 through 49. These involve multiplication. You're asked to do 41 through 49 odd. I'm going to do a couple evens. Number 42. 42 says 2i, open parentheses, 3 plus 4i. Well, remember, in algebra, when we connect a term to a parentheses or any sort of connection at all implies multiplication. Connected means multiplied. I'm going to take the 2i and multiply by this term and by this second term. This is the distributive property. So 2i times 3 is 6i. Now 2i times plus 4i will be a plus 8i squared. Again, thinking of the i's like x's. X times x would be x squared. 2 times 4 is 8. I times I is I squared. Well, we learned previously that I squared is negative 1. So this statement becomes 6i plus 8 times negative 1. Well, 8 times negative 1 is a negative 8. We can re-express this as 6i minus 8. And typically we write the real part first and the imaginary portion second in our complex number. It would have been an equivalent statement to say 6i subtract 8. Instead we wrote negative 8 plus 6i. Alright, one last one. Number 46. Again, you're doing the odds. I'm showing some even similar problems. 46 has 2 minus 4i, 3 plus I. Alright, again, connected means multiplied, so we're going to multiply this parentheses times this. We simply use the distributive property 2 times. You may have heard the acronym FOIL. Alright, I'm going to say distribute. I'm going to take this 2 and distribute it across this parentheses. 2 times 3 is 6. 2 times I is a 2i, and you can hear my cat in the background, I'm sure. Now I will take the negative 4i and distribute it across this parentheses. Negative 4i times 3 will be a negative 12i. And a negative 4i times I will be a negative 4i squared. Using this acronym FOIL, F stands for first. That is, 2 times 3 is 6. O for outside. 2 times I is 2i. I for inside, negative 4i times 3 is a negative 12i. And L for last, negative 4i times I is a negative 4i squared. If you've heard this before, it's just a distributive property. Alright, now we can simplify this. 6 is our constant. 2i minus 12i is a minus 10i. And this negative 4i squared, again, I squared is negative 1. So, we have a negative 4 times negative 1. Well, negative 4 times negative 1 is a positive 4. So this is 6 minus 10i plus 4. Well, lastly, we can combine these two like terms. 4 plus 6 is 10. So finally, this expression is 10 minus 10i. All right, with these examples, you should be able to work all the problems from 1.6 and 1.7.